So in this series of videos, I'm going to look at the sample test problems for test number 3. We'll start with number 1. The musical theater group has determined that if they price tickets at X dollars apiece, their revenue R is modeled by the function R of X equals 3000X minus 100X squared. Part A says find the vertex of R. So first thing we should know that the word vertex is specific to parabolas, and we know that the graph of this function is a parabola because the leading term there is an x squared. So that's a quadratic equation. So it has a parabola, so the word vertex makes sense. And in order to find the vertex, we're going to use our formula x equals negative b over 2a. And in order to use that formula, it might help us to rewrite this in decreasing order, so negative 100x squared plus 3000x. And so the a is negative 100, and the b is 3000. So we plug those into our formula. So we go negative 3000 divided by 2 times negative 100. So that's 3000 over 200. I guess they're both negative, so it's all positive. And we should get 15 when all is said and done. 15 is the x-coordinate of the vertex. In order to find the y-coordinate, we need to plug 15 back into the function. So let's find r of 15. So it's 3000 times 15 minus 100 times 15 squared. And if we do that, you can check it on a calculator. I think it's this. And so that's the y-coordinate of the vertex. And so the vertex, putting it together, is 15, 22,500. Part B, what does the x-coordinate of the vertex tell you about this situation? First, we need to think about the graph. You don't need a good sketch, but you just need to understand which way this parabola is turning. Because it's a is a negative number, that means this parabola is a downward-facing parabola. So I don't know exactly what it looks like, but I know it's going to be something like that. And the vertex, therefore, is this point way at the tippy top. So this is somehow at 15 and 22,500. And so the x-coordinate represents, let's see, x was the number of dollars the tickets cost. So in order to maximize revenue, tickets should be sold at $15 a piece. It's important to get that word maximize in there because that's what's special about the vertex. In this case, it is a highest point. And then the part C, what does the y-coordinate of the vertex tell you? So the y-coordinate is 22,500, and the y-coordinate is the value of R. So in this case, 22,500 is the maximum revenue. And that maximum revenue is attained by charging $15 a piece. Part D says find the zeros of this function. So that word zero, you're supposed to know, means set the whole thing equal to 0. And in order to solve this equation, of course, you could use the quadratic formula because it's a quadratic equation. But the easiest thing to do is to factor. And in this case, you can take 100 and you can take an x out of both terms. And so if you take 100x out of the first term, we get 30. Take 100x out of the second term, we get x. And now we can split this right down the middle and set the two pieces equal to 0. So either 100x is 0 or 30 minus x is 0. Divide by 100, we get x is 0. Move the x over by adding it to both sides, and we get x is 30. So those are the two zeros, 0 and 30. And then part E, what do the zeros tell you about the situation? So it means that if you charge either of those zeros, if we charge $0 or $30 per ticket, revenue is 0. So to be clear, the zeros of R correspond to the revenue being 0. And the X values that we found were the dollar per ticket charges. So if you charge $0 per ticket, well, it seems to make sense. You'll make no revenue. Somehow, if we charge $30 per ticket, we also make no revenue. I'm assuming that this has something to do with the fact that the more you charge per ticket, the fewer people are going to be willing to buy the ticket. So apparently charging $30 per ticket is too much to entice anybody to buy. And so I guess it means we didn't sell any tickets. And that's why the revenue is 0.